Matlab refers to Matrix Laboratory. When you open the program, you will see current folders, command window, workspace in which variables are stored, and the command history in which earlier syntax is being stored, preserved as in history. So let's get started. When we press present working directory pwd, it displays the path in which its compiler run. ls refers to list. And let's assign a variable a with a value 5. It gets displayed on the workspace. Similarly, if we call b, which is not defined in workspace, it will display as undefined. We can assign b as a number by just equating it to 6, let's say. And then now we have b and a in workspace. So we can assign a third variable c with a mathematical expression consisting of a and b. And let's try to clear only variable c. So we'll write clear space c. And if we want to clear all variables in workspace, we'll type clear all. And for clearing the screen, like we define a as 5, now we'll start with the matrix definitions. So matrix are defined using square braces. Let's say a square braces of 5 will define it to be 5. With spaces, it becomes row. With semicolon or the suppressor, it becomes column. So let's try defining a 2D matrix. So we'll be writing square braces like matrix, then a row, suppress it, then another row, suppress it, and the third row. And no need to put suppress. So it gets defined, like 2D matrix gets defined. Let's clear the screen. So we have in our workspace A, let's try extracting each and every value. Let's say we want 9. So we'll just put 3 by 3, 3 comma 3. So first space 3 refers to the row selection and the second space refers to the column selection. Let's try with another one, like we accessed now 2. Similarly, we can access some rows as well as some columns. So we should remember that the first space or attribute is for row definition. Let's try accessing 1, 2, 3. So we want all column like first, second and third, like the vertical spaces are called third. So we'll be putting 1, 2, 3, and row we want only first. And as we execute it by enter, we'll have 1, 2, 3. Similarly, we'll try for the next row, let's say third row. So we get the values. Let's try with different idea. So let's try defining that selection, like let's say first row and the first column and the third column into a variable b. So we'll define b equals a, and we know the row spaces comma the column spaces. So we'll define in row we want all rows like 1, 2, 3. So 1 space 2 space 3, and we want first and third column. So 1 space 3. So we get the values like first column and the last column. And when we use suppressor, so it will just suppress the value. It suppresses the display, but it just gets modified or it just get appended in only workspace. Let's try with another strategy. Let's say c equals a square. Like we want to square the matrix. So it's possible in a square matrix, we can multiply it. But if we define b as a row matrix, let's say 2 space 4 space 6. So we have a matrix 2, 4, 6, a row matrix. So let's try to square this matrix. So mathematically it should give an error. Of course it gives an error. So, but we can it have a power like a element wise operation as well. Like we'll be using a dot or a period operator before any like raise to multiplication or division. Like these 3 arithmetic operator or these 3 operators can be element wise propagated that way. So again, we have A matrix, and we can find it satisfies every matrix relation we have. Let us see equals A into B transpose. So it gives, like, transpose refers to apostrophe. Like when you write A transpose, like A transpose, it gives you the transposed nature. Similarly, you can use inverse also. So let's proceed further. So we can now define A matrix as a square, let's say, and now we'll see an appending a matrix. So we'll just insert like 4 comma 4, the fourth row and fourth column element as 0, so it gets appended. Similarly, we can modify each and every element of the matrix. Like any matrix element you want to modify, you can directly overwrite it with your definition, like your expression equals to some value that way. Let's proceed further. If we want to append a column, let's say 1 to 10, so this might be a way. So we have that a row matrix, a row defined with 1 to 10. So is there any process like similar nature, similar sort of idea we can append easily? So this is one of the I value. Just do donkey work or the hard work, like putting all the values. Or the next smart work might be using colon. Colon refers to continuation. So like if you write 1, it's the initial value, and 10 is the final value. And the default step in Matlab is 1. So if you write 1 is to space like 1 colon 10, it refers to spacing of 1. So you can try with different sets, let's say 1 to 2 and then 1 to 5. We know the value with the step size as well. So if you modify the step size, so we can have different array structure we want, but in a pattern that way. So let's proceed or let's try reducing that step value with 0.5. This technique will be useful in further sessions. So now we can define array or a matrix in our trend, like a very large matrix you can make it. So let's clear everything. And you can call the matrices using history, command history, by just pressing your up cursor key. So let's try with some mathematical values or the constants we have. Let's say pi. So it's predefined in this package. Don't try, like never try using like 3.1416. It seems to be constant, but it's not. It's like to the power of 16. It's defined that way. And if we write a function in Matlab, its default is in round bracket. So if you want to define sine of pi, which is in default as a radian, so it gives 0. But note here it is 10 to power minus 16. E refers to 10 to power minus 16. That way it's almost negligible, almost near to 0. Similarly for pi by 2 it gives 1. But what if we want in degrees? So you will have to define d, like sine d, and it's a function, so round bracket. Like if you use it for first time or some like beginner level, so you should say it in that fashion only, like function, sine is a function, so sine and then the round bracket that way. Like if you practice, it will be good. Like let's try with exponential. So exponential exp, it's a function, so round bracket, and define some attributes or arguments inside that function or the braces. So you can define any values, like any possible but mathematically correct statements. So let's clear the screen.